Hello, thank you for joining us today for the Esri webinar on the power of ArcGIS and Predictive Analytics in water utilities. I'm Maria Lamas, Marketing Programs Lead of the Infrastructure team here at Esri, and I will be your moderator for today's webinar. We're going to get started with some housekeeping items. So we want to remind you some tips for best webinar experience. We recommend you close email, instant messengers, and any other programs not currently in use as they may interfere with a smooth reception of the webinar, causing slide buffering and poor sound quality. We do have a survey post the webinar, so when you do close out of the webinar, there will be a pop-up screen and it will load. That will help us improve webinar programming. So if you can please respond to that along with some questions to help you with your needs after the webinar. Also, there's a chat window where you can ask your questions. We encourage that you post your questions there throughout the webinar, and we will have a Q&A so we can get to those later. Also, we'll have a set of poll questions. We'd like to participate and interact with you, so if you can respond to those as we go through the content here today. Also, this webinar is being recorded and will be available online. You will receive email with links to follow for the webinar, so be on the lookout for those. Next, we want to make you aware that this is part of the webinar series, Put Your Data to Work with Analytics. This link shown here will take you to the webinar series, and you will have access to the webinar recordings on this page. So feel free to visit there and bookmark that and share it with your colleagues. So with that, I am pleased to introduce you today to Jonas Regis. He's our Esri presenter, and he's our solution engineer for the global water practice at Esri. Jonas, let's get started.
Thanks, Maria. So in this webinar series, we've already seen how to leverage tools within ArcGIS to better understand water loss and work with very large data sets. We've seen how insights for ArcGIS can take massive amounts of data coming from a variety of different sources and analyze it in a single browser-based workbench. We've seen how GeoAnalytics Server can process massive amounts of data in minutes instead of days. I work with many different water utilities across the country, and very often they tell me, we have tons of data, but we're not doing anything with it, or we're not doing enough with it. In other words, they're data rich, but information poor. And decision makers at those utilities need tools to turn this data into understanding. So this webinar is focused on GIS and historical work order data. So vector data representing the location of water mains, the associated tabular attributes like install date, material, diameter, and historical work order information or service request information coming from critical systems like billing, CMMS, or asset management. And also bringing in information from staff, experiential knowledge or institutional knowledge, and bringing all that together to make better decisions. So we're entering an unprecedented time in modern history where much of the underground pipe infrastructure that we rely on to provide clean, safe, reliable drinking water is reaching the end of its useful life. I'm sure many of you are familiar with the recent study that found main breaks in the US and Canada are up 27% in the past 6 years. And this is coinciding with a generational shift in the industry where the experienced operators, engineers, and managers with decades of firsthand knowledge of the installation and maintenance of these systems are reaching retirement age. Water utilities are going to replace a huge amount of infrastructure in the 21st century. And to do this in the most efficient way possible, they'll have to leverage their infrastructure data, GIS data, repair history, and that institutional knowledge. And that's an immense challenge. But fortunately, there are emerging technologies that put that solution within reach. Spatial analysis and machine learning tools that allow us to make better use of our historical data are more accessible than ever before. Machine learning is a subset of artificial intelligence and can be defined as the ability for computers to combine data and logic, or learn, without being specifically programmed to do so. Simply put, machine learning is the creation of logic from large amounts of data. Now, there's great excitement about the potential of these tools in our industry. In this webinar, I'm going to cover how to use ArcGIS Pro to explore your data and prepare it for predictive analysis. I'll provide an example of machine learning libraries like Python scikit-learn that can be applied to your data, and I'll also demonstrate how to use simple configurable apps in ArcGIS Online to visualize your results and provide decision support tools to executives. Now, we'll also be taking a look at insights for ArcGIS and how it can be used to tackle that challenge of capturing institutional knowledge. There's knowledge associated with the historical data that you have at your organization. Most work orders or break reports from the past 2 decades have a living memory associated with them, and very often, this experiential knowledge can help fill the gaps that exist in the historical record. Powerful visualization tools like Insights can function as a bridge between different departments and different types of people. So I'll demonstrate how technical staff can use Insights to get the historical data in front of non-technical staff like operators, engineers, or decision makers. But before I jump into data prep in ArcGIS Pro, I think we're ready for our first poll question.
Yes, we are. Thank you, Jonas. Let me launch this poll here. So Jonas quickly talked about Insights for ArcGIS. Are you using Insights for ArcGIS currently? We're curious for the audience on the line. And it looks like some of the audience is, but a majority haven't started using it yet. So I'd encourage you to participate in the poll. For the most part, everyone has responded. So thank you for participating. I'm going to go ahead and close the poll now. Thank you, Jonas.
Sure thing. Great. So hopefully we'll be able to provide some examples of why Insights is a great tool, not just to perform spatial analysis, but also get more and more people looking at this data and getting their insight and contribution. But I'll start with a demonstration of ArcGIS Pro and how we can use this powerful connected desktop application to prepare our data for predictive analysis or just for visualizations and tools like Insights and dashboards. So in any process like this, wrangling the GIS data in work order or repair history is often the most time-consuming part of this entire process. So I'll cover 2 examples and try to point out some best practices for data management here in Pro. And just keep in mind, this workflow is relevant whether you're looking to build a data set to leverage machine learning tools, or just you want to build a data set for historical analysis to support decision making. So understanding where leaks and main breaks are occurring and under what conditions, both spatial and temporal, is essential to better long-term repair and replacement decisions. Now, this first example I'll share is of an agency using a GIS-centric work order management system, in this case, CityWorks AMS. Every work order in this system is associated with an asset in GIS using a unique identifier. This is a best practice because it allows us to accurately track what transactions occurred on what asset. So I start by bringing in my water mains, my GIS feature class, and stripping it down to only the key attributes that are relevant to this particular problem, leaks and main breaks. So here we've got the installation date, material, water type, measured length, diameter, and unique facility identifier. Now I also need to extract the work order history from my asset management system. And this can, in this particular example, that consists in 3 tables containing details and dates about the work order, associated cost information about the particular task. And this is really critical because if you remember in the first webinar, we asked the question, are you able to quickly generate a report of how many leaks or how many breaks occurred last year? What about last 5 years, last 10 years? do you have a system that you can quickly query and extract out the type of work that you need based on task names or descriptions? That's an important consideration and very often an initial stumbling block. And then finally, and most critically, the table that associates every single work order to a unique feature in GIS. This is a really great thing to do because not only do I have a complete history of work that's been performed on assets that exist, but I'm also not tracking work orders on assets that have been replaced. So to bring all this information together into a single data set, I'll start by joining these tables together. So I can just go to my table and add a new join. And what I want to do is join these three tables based on their work order ID. And in this case, I don't want to keep all of my target features. I only want the records that match between all three tables. And in a perfect world, most of these should match exactly, and I shouldn't be dropping records every time I perform an inner join. You know, there will always be an associated record, but that's not always the case. So it's important when joining these tables together to keep track of how many records are being dropped. Now, for the sake of time, let's just say I've joined these three tables together, and now I want to join them to my water mains. So I'll go ahead and perform a join on my mains, but this time I do want to keep all target features. So I'm joining on my facility ID, and I'm also joining on my feature ID in the work order table. And I want to keep all of these target features because I want the output to contain all records, all segments of main that had a break, but also segments of main that did not have a break. So I've got a complete record of all my assets, the ones that broke, the ones that leaked, and the ones that didn't. So after I complete that join, and then summarize the count of breaks on each unique asset, I'll be able to visualize that in a map and perform some analysis. So that's what this layer is representing, the complete count of breaks on each one of these main segments. And it's important to pay attention to how this data is organized. So I've got a duplicate record for every feature that experienced a break. Now you may be wondering, why not use a relationship? Why not create a related table for each unique feature in GIS that contains this unique break information? Because in a way, I'm duplicating certain things like the material and the water type, etc. Well, the reason for that is the machine learning algorithm that I'm going to use later on requires a single data set, basically one giant table with all my records in it. So that's why I'm formatting it this way and symbolizing it based on my break count. But we can do a lot more in ArcGIS Pro than just joining some tables together. Leveraging spatial analysis and the environmental data that's available through the Living Atlas of the World is really the key strength of a GIS application like ArcGIS Pro. So I mentioned before, this is a connected desktop, which means I'm connected to the Living Atlas of the World and all the information that Esri and the Living Atlas team makes available to all our users. So one of the key data sets for analyzing leaks and main breaks are soil information. So if I search for soil corrosivity, I can bring in layers like USA soil corrosion, which comes from that SSURGO data set. And this is really critical because environmental information can often explain why assets have failed. You know, if I have the premise that a 100-foot long, 6-inch diameter steel pipe will perform differently when placed in a dry, sandy soil versus a groundwater saturated corrosive clay, we can start to explain potential premature failure conditions. Corrosive soils drive up the total cost of ownership and should be brought into our risk calculations. So once I bring that in, I'm able to visualize, in this case, what are the most corrosive soils in terms of steel across my service area? And we can get a better look at all that information. and we can join or enrich our GIS features with that information to contain steel and concrete corrosivity from that soil data set. So I'll scroll over. This are my water mains with all the information from the work orders, and then steel and concrete corrosivity and our break count. But that's not all. Finally, I'll take a look at where our mains intersect major infrastructure. And this can be pulling from GIS data from our agency, from another agency, or again, we can leverage the Living Atlas. So if I want to bring in major highways and railroads and join them to my water mains because we found that the vibrations caused by major transportation infrastructure can have an impact on underground assets. Over time, that causes leaks and breaks to occur prematurely. So I can search for USA freeway system, bring that information into my map, and then perform a quick buffer or a spatial join to get that information onto my water mains. Now I can do the same thing with railroads. Search for railroads in the Living Atlas, add them to my data, and include that information in my data set. So now I've got a more complete data set, which has brought in environmental information and performed spatial analysis to enrich it with different attributes. And I can continue on with this. I could bring in elevation, slope, population density, any variable that we think will impact the leaks or breaks on these features. Now, it's great if you're using a GIS-centric work order or asset management system, but I know many agencies are not. And I know many agencies have recently migrated, but you've still got decades of work order history that you want to bring into this analysis. So I'll quickly cover how to address this problem if you don't have that unique ID association. So here's another example. I've brought in my water mains. I've stripped it down to the bare necessities, material, diameter. Sometimes we don't even have install dates. And I'll cover certain ways to get the best idea of when pipes were installed when we do the insights demo. But basically, bare bones, GIS data, location, length, material, diameter. And then I'll also bring in my work orders for leaks and main breaks. Now, this could be an example of information coming from an actual enterprise work order management system, or if it's just being maintained in a spreadsheet, or like the leak investigator solution, just an independent layer in GIS. In this example, it's coming from a work order system where each work order has an X and Y coordinate associated with it. Now, that's not always the most accurate measure. Very often it's the nearest address or the XY coordinate of an intersection. So when we go to join this information to our mains, we've got to do some spatial analysis and unfortunately introduce some potential for loss of data integrity. So really the operation to perform is a snap of all of these leak points, all of these work order points onto the water mains, and then followed by a spatial join to update the mains with the information from the work orders. Now, if we have a situation like this, maybe it was this main that actually had the leak, but when I snapped, it was a little bit closer to this main. That's a loss of data integrity. So this is a process, if you're going through it, to really review with as many people as possible and come up with the best possible parameters for the snap operation. So again, for the sake of time, I've already performed the snap. I've already performed the spatial join. So I'm just going to load up the attribute table of what this looks like once we've performed that operation. So here are my water mains. Now we've got that leak work order information associated with it and all the status, anything else that we might need like priority. And again, I can perform that same spatial enrichment So I can go up to the Living Atlas, and instead of bringing it in via Pro, I just wanted to show that there's an entire soil map unit downloader application that's been created by the Living Atlas team. Really just to make that point that the Living Atlas is more than just a data repository. It's data, maps, and apps that that team has built to make it as easy as possible to access all of this information. So whether I'm bringing in feature services in Pro or downloading map packages and working with that information locally, please, I encourage you to leverage what the Living Atlas team's put together. Now, the last step in this process, once I've completed my data set, joined the soil carcivity information, is to share it out. But there's one thing I forgot to mention, and it's a really valuable thing to do, is just simply normalize the break rate. Once you have the count on each main, normalize this break rate by dividing the total number of breaks that occurred on a certain diameter pipe with the total number of features of that diameter to get us a rate of how often is this type of diameter and this type of material breaking relative to the total number of features. Because, obviously if we have 80% PVC in our system, we'll probably have more leaks and breaks on PVC material, but that might not have the highest break rate. More than likely it would be, cast iron or ductile iron pipe that's breaking the most. So here I've got my starting point. I'm going to remove all of the layers I don't want to actually publish and share out. So I'm going to get rid of the original data. I'm going to keep my original leak locations. I'll keep my enriched data set that has my break counts, my break rates, and all the environmental information, and these two tables. Then I'll go ahead and share this to my portal to not only make it available to other users, but also to build an insights workbook with this data. So I'll go ahead and share this as a web layer. And again, for the sake of time, I've already shared this information, so I would just give it a quick summary, tag it, and then go ahead, analyze, and publish that data to my portal. So before I jump to the portal and take a look at this information and insights, I think Maria's got another poll question for you.
Great, thanks, Jonas. So Jonas went over some data management best practices, and we saw him perform some analysis using work order data. So we're curious to know if or how you're tracking your work order data currently, whether that's paper, spreadsheets, you're actually using a work order management system, or if there's any other ways that you are tracking your work order data. Excuse me. We're curious to know. So again, the question is, what are you using to track your work order data? Are you using paper, spreadsheets, a work order management system, or CMMS, or other? If you are using other, I see some people are putting other. You can put in the chat window or in the question dialog box what you are using to track that work order data. We're just curious to know how different users are seeing this information and this data. So it looks like 60% of you are using a work order management system, and about 20 are using spreadsheets, and then the rest are either paper or other. So thank you guys for sharing that. I'm going to go ahead and close the poll now. We have one more to follow up with those that did say that you are working in a work order management system. We're curious to know how many of those systems that you are using or the system that you're using is GIS-centric. Does it tie to your location data of your assets? So I'll go ahead and leave that available for a little bit for those of you who did respond that you are using a system. It looks like it's about 50-50 that your system is GIS-centric. So thank you for sharing. We appreciate it. It's always interesting to see all the different, where everyone is at. So thank you so much. Back to you, Jonas.
Thanks, Maria. And that's really great to hear that more and more people are moving to GIS-centric systems for asset management and work order management. It's really key to be able to perform this type of spatial analysis, especially going forward. So next up, I'll jump to my portal. And as an Insights user, I have access to the Insights application. And what I'm going to do is build a workbook that I can share out that information that I just prepared in ArcGIS Pro with other staff at the utility, with the hopes to not only validate the information that I created, make sure that I performed those queries properly, that I extracted the data properly, but also to make sure I'm not missing anything that may be available in our organization. Maybe there's a spreadsheet or a database that I'm not aware of with really valuable information. Or maybe there's someone who's able to take some time and let me know what they recall about certain types of work or certain developments and projects, and get that information into the data so we can perform better analysis. So to do this, here at my Insights homepage, I'll go ahead and select New Workbook, and I'll be prompted to add some data to my new workbook in Insights. So I'll quickly cover what my options are here. Obviously, I can bring in my authoritative information, my GIS content. I can also leverage information from my organization and the wealth of information available in the Living Atlas of the World. So that's not just something I can bring into Pro. It's connected to all of these different applications, including Insights. Importantly, I can bring in any information that I'm maintaining in a spreadsheet or CSV file, whether or not that's inherently spatial information. So by spatial, I mean, does it contain an address or a latitude, longitude coordinate, or a unique identifier where we can join it to our GIS data? Even if the answer to all three are no, we can still bring that in and use it in our analysis. Then finally, and probably most exciting, is the ability to connect directly to enterprise databases in my organization. So that's SQL Server, SAP HANA, Azure. I can bring in tables directly from enterprise databases and use them in my analysis. But in this case, I'll simply search for that layer I just created in Pro, my leak analysis, which contained my original data, my work orders for leaks, my GIS data that's been enriched, my water mains, and those two break rate tables that I created simply by normalizing the number of events on this data. So the first thing I like to do here, especially if operators and managers at your utility haven't seen the distribution of work, basically just bring in the location of all the work orders for leaks and visualize it on a map. Step one, simple visualization. And very often, just by seeing the information spatially, we can check to make sure we've done our extraction correctly. If this looks like way too many or way too few or in the wrong areas to an operator or supervisor or manager, someone who's responsible for this work order management system, you can immediately go back and correct those errors before spending any more time with bad data. So I like to leverage different visualization options. Again, keep it very simple and straightforward. Show the leak points, where things occurred, and also visualize a heat map to see the areas of higher concentration. So this is a great starting point, just visualizing where things occurred. But next, it's important to start leveraging the process we just performed of enrichment and processing of that data. So I'll jump to a new page, and I'll bring in that same leak analysis data. And here I'll start to visualize information on the mains themselves. So first I'll take a look at the break count on each main. So the lines of varying thickness here after they draw will show what mains have had breaks and the larger, thicker lines representing the mains that have had more breaks. And I can change the symbology here and what this looks like. And there's certain nuances that you may discover when working with the data and insights, like when I visualize this information based on the numeric break count field, all the mains that I have in 0 show up in red. So I nulled out those values and created a new field called break count display. And I can look at the actual data behind this right here in Insights and calculate new fields. But there's certain little things that you may want to prepare for end users, right? Like a non-technical person may be able to learn to use an Insights workbook, but it's good if you can set up the data for them so there won't be any little gotchas and they'll be seeing the best possible visualizations necessary. So my 2 different break count fields, you should see them here and here. Here's my original break count. Here's my break count display, where I simply nulled out the values that were 0. So the symbology looks a little sharper, and I can clearly see the mains that have had breaks versus the ones that haven't. Now I can also take a look at breakdowns by material. So I'll go ahead and drag material and break count into a new chart. So I can see, okay, what types of material have the most breaks. So it looks like PVC has the most, followed by ductile iron, followed by asbestos concrete, and galvanized iron. Next, I'll take a look at the breakdown by diameter. And I don't want to use diameter as a number in this case. I simply want it as a string classifier. And Insights recognizes that I changed the type of that field without doing anything but saying, I want to use this number as a string, bring it into a chart, and it automatically knows the right chart to bring up. So there's some really cool, just intuitive behavior here in Insights. It's great not having to leave this application to do things like that, change how a field is used, or create a relationship on the fly. So here's my breakdown of diameter. And here's another way to catch potential data issues, or maybe you're looking at something that you don't entirely understand. Maybe there are leaks on service laterals included in this data set, these really small diameter pipes that I don't want to include in my main break analysis. Well, if I'm a GIS person, I'm not probably going to be savvy to all the little nuances of this work, but people in operations who are understanding these work orders and the data I'm looking at, absolutely. So that's why it's great to just get this information in front of people in an easy way to understand. And here I'm also going to bring in those tables where I normalize the break rates just to simply get a look at it. What type of material or what type of diameter pipe is breaking the most? What type of material is breaking the most? I can bring these into these simple bubble charts and visualize that information. So this can really help. Remember, we've got the most breaks on PVC pipe. However, if I scroll down, you can see that the highest break rate is actually on galvanized iron. PVC looks to be about 3rd. So we can also visualize that soil corrosivity information. So the last page I'll create here, again, bring in that same data set. But this time I'll look at the information that I enriched these mains with so we can see what types of material are in what types of soils. Let me go ahead and remove that card, and I'm going to first bring in my mains with steel corrosion, different rates, and visualize that on a map. And then I'll bring in, after I set up this map card to look the way I want it, draw my mains. I'll zoom in a little bit more. change the background. So I've got a map, and very often I like to create a corresponding chart with the same information, just visualized a different way. So in this case, create a donut chart. And I can just quickly look through the different types of names. Now, I can also filter this down to only show the types of materials that I'm interested in. So remember, this is steel corrosivity. So let's remove everything that is not impacted by soils that are corrosive to steel and only look at the materials in question. Now we can get a much better idea of what materials are in the relevant corrosive soils. And there's a new capability on the latest release of Insights where I can actually create advanced filters like this, build out my expression. So, if I wanted to break down material and diameter, I could create this filter. And then when I go and share this page out with users in my organization, they can actually apply the filters that I've set here in Insights without being an Insights user. So there's some really great functionality, of course, for the Insights power users that you want to give access to the full capabilities, but also those read-only users in your organization can still really benefit from those advanced filters that you can set up and share out. So that's some really cool new functionality within Insights. The last thing I'll do in this workbook is just create a similar view for our concrete corrosion. I'll bring that into a map and basically build out the same thing that I had up top. Look at rates of concrete corrosivity. Give it a better background. Drag my layer into a new chart. Apply a filter where I'm only looking at, in this case, my AC asbestos concrete mains. That's what's impacted by these types of soils. And now I can look through this information. So basically what I've done is create a fully functional dashboard for users within my organization that I can now save and share out and provide to them, right? So I've given them a starting point. I know the data is good. Now I have a fully functional dashboard that they can take one step further and perform spatial analysis. They've got the ability to enrich all of this information with information from the Living Atlas, to perform on-the-fly aggregations or different types of spatial analysis. So really the vision here, or at least my idea is this is the way to convert people's institutional knowledge into codified business rules from which to make decisions. So people who know what they're doing, understand the data, can perform analysis and insights. Every step I take in an Insights workbook is tracked in this analysis view. And this can be updated with new data and shared around the organization. And the idea is to create codified analytical processes, basically the rules to process the data to create decision support tools for the end users. So that's really the idea, is to get this information in front of as many people as possible, validate your data prep before moving into any type of predictive analytics or plugging it into an algorithm. However, once I've got a data set that I've confirmed is as accurate, complete, and up-to-date as possible, it's time to start looking into the potential of machine learning and predictive analytics. So in this example, I'll quickly cover the scikit-learn library that we can bring in to a Python script. I'm going to share a few examples in Jupyter Notebooks and apply to these data sets that we're creating. But I also want to point out that there are a variety of machine learning capabilities and tools already within ArcGIS. One really exciting one is image classification for any utility or municipality that's performing impervious surface analysis. So calculating stormwater fees based on impervious surfaces coming from imagery, aerial photography. So if anyone's familiar with that process, there's potentially a lot of cleanup work involved. There's really amazing things going on with the ability for machine learning tools to speed up that image classification and make it a lot more accurate. But in this case, I'm just providing an example of a library that can be brought in to the open ArcGIS platform and perform analysis on your data. So I've imported some of these tools into a Jupyter notebook, which is an interactive scripting environment that lets me take advantage of powerful visualizations like tables, maps, and charts. So this helps me while scripting and also makes it easier for others to understand what my scripts are doing. So let's take a quick look through this one. First thing I'm doing is getting the data together, taking a look at it, starts with a cursory glance at the information available, identifies columns with missing data. And the format here is also important. Remember, I mentioned that that data set that I created contains all the water mains, whether or not they've experienced a break. So this allows us to look at the entire system and make better predictions. Now, building a machine learning model is an iterative process and involves taking different approaches and checking the results. Training the model using historical data is essential, and this can be called predicting the past. Basically, can our model successfully predict the breaks that have already happened? And how many breaks is it predicting that didn't happen? So just to make it clear, if I've got 20 years of historical main break information, I train the model based on 15 years of historical data and then attempt to predict the next 5 years. So, year 2000 to 2015, I train the model with that data and then attempt to predict 2016, 2017, 2018. And that really determines how well it's doing, how well it was able to predict events, and what was it predicting that did not occur. So to answer those two questions, can our model successfully predict the breaks that have already happened? And how many breaks is it predicting that didn't happen? The answer is recall and precision, these two values. So if our model, just use a small scale example, our model predicted 15 main breaks and only 10 of those actually occurred, it means that our model was able to recall all the events, but it was not very precise. So precision is the ratio of a number of events we can correctly recall to a number of all events that are recalled. And that's what we're looking at in these charts. So here we're evaluating the recall and precision of 3 different algorithms: logistic regression, support vector machines, and random forest. Now, once a model's been determined, it's time to operationalize and test it. And we can look at the different attributes based on their order of importance. So in this example, we identified seasonality as an important attribute, which suggests we should bring historical temperature data into this analysis to see if more pipes break during unusually cold winters. So it's an iterative process and very likely will involve going back and doing more data prep, gathering more information, and plugging it in. Predicting main breaks can be a challenge for machine learning tools because it's an essentially rare event. That's why we're not using accuracy to judge the effectiveness of these models. If I predict every year that no breaks are going to occur, I'm probably going to be 99% accurate, but I'm not going to provide any value to decision making. So it's an iterative process, takes a lot of work, but the goal of this entire process is predictive analytics, a reliable model that forecasts what pipe segments will break and when. Now, this is a simulated example. I just put together what we want this to look like. These are not actual results that we've created with a machine learning algorithm, but what this app allows me to do is basically scroll through the time range of the future to see what pipes are predicted to break and when. So I can select any particular pipe in the system and see its predicted break date, and then make better decisions based off of this. And the goal is to have this be a real model at many different utilities that have gone through this process, and that will allow them to make better, more informed decisions on capital improvements and repair and replacement schedules. So I've got some recommendations based on that, but before we jump to that, I think we've got a last poll question.
Yes, thank you, Jonas. Pretty exciting tools that you just demonstrated and went through. So we want to poll the audience here. Is your data ready? Similar to how we showed, right? Do you have your work order data ready and it's GIS centric? And are you ready to use tools like this? Meaning getting into the predictive analytics. So we're curious to know after you've seen this, how ready you are and your readiness to start using and leveraging tools like this today. It seems like there are quite a few of you who are ready. So that is exciting. We're excited for you. And for those who aren't so ready yet, there's a lot of great best practices that Jonas showed and demonstrated today that you can take away from. So I'll wait a couple more seconds for those who are on to share their feedback. And thank you for those participating. We appreciate the response. So I'll go ahead and close that now. All right, Jonas, back to you. Thank you.
Thanks. So let me just jump back to this slide and quickly summarize what we covered today. We looked at data prep in ArcGIS Pro, processing data coming from GIS, and tabular data coming from critical systems, work order management, asset management, essentially billing, to create a robust data set, enrich it with environmental and temporal information, and then plug that into an insights workbook, and then eventually plug that into a machine learning algorithm to perform predictive analytics, help me better understand what will happen in the future. Basically turning that data into a solution for a decision maker that helps them make better repair and replacement decisions. Now, really my recommendations right now are to first focus on your data. Focus on that data prep and make sure you have a process to extract the right information from these different systems. You really want to make sure that you have the most data available to you in that data set and that it's complete, up to date, and as accurate as possible. You know, a lot of these tools are garbage in, garbage out, so you want to make sure you've got a great starting point. Follow best practices, adopt a GIS-centric CMMS, work order management system. Make sure that you're tracking all the transactions that occur against your assets based on that unique identifier. So you're able to bring in this history. Use tools like Insights to share your data and to codify as much institutional knowledge as possible. And then engage the community, right? Leverage everything that our machine learning team here at Esri has put up on GitHub. You know, leverage what our partners are doing. Attend events, attend our conferences, and talk to people about this. We're really just at the emerging stage of applying this technology in our industry. And then finally, leverage the emerging Esri partners who specialize in this specific application of machine learning to address this problem of leaks and main breaks. You know, there is a lot of work and thought that goes into developing these solutions. So leverage the true experts who are doing this constantly, who see data coming from all over the country and potentially the world, and are even learning from all of that data they're processing. So finally, I'd like to recap what my colleagues and I covered in this webinar series. We looked at how insights for ArcGIS can be used to analyze historical data. We saw how GeoAnalytics Server can analyze big data in space and time. And what we just did today is take a quick look at predictive analytics, using AI and machine learning to understand why events happened, and using this understanding to better predict what will happen in the future. So it's really exciting. The technology to accomplish this exists now, and Esri and our partners are ready to help you get started. We need to provide the next generation of water professionals with the tools to better manage our drinking water infrastructure in an increasingly uncertain and challenging future. Back to you, Maria.
Thank you, Jonas. Moving on to our next part, we're going to share some information here We do have this page available for you to go to if you are curious to look at how other utilities are using insights for ArcGIS, specifically within the water industry. So you can go down to this link here below and you'll see some information there available for you. Following, we want to remind you that that we do have our water conference coming up. Again, Jenna shared some of the ways, right, that you can take this information and apply, and is also learning from your colleagues. We'll definitely be talking about analytics and insights along with other tools within the ArcGIS platform at the water conference. It's a great way to network with your peers and see how they're using this technology to really transform their business and the way they work. So if you do a quick search online, you'll be able to find that link there. So moving to our next reminder, we want to share this link here below. You will be able to find our previous 2 recordings on this page as part of our webinar series. And also, this webinar is being recorded, so you will be able to access this webinar recording on this page as well. So with that, we want to go to Q&A now. Jonas, we did get a series of questions. So earlier on, you went into ArcGIS Pro, and we did get some information from, some questions from our audience. So I'll start with the first one. When you were doing the data management process of those 3 different layers, our user would like to know what geoprocessing tool you were using for those joins.
So for the joins themselves, I'm just performing joins on the data. So, when I go right click, select join, it'll open up that add join tool. And one thing I skipped, so, for the sake of time, I didn't walk through the entire process, but once I've created a join, that's a temporary join. If I want to create a permanent feature class from joined information, what I would do is add the join and then go to data, export features, and export that to a new feature class or table that now permanently contains all the joined information.
Great. Okay, another question here on this. We have George asking, during the snap join, is there a way to add a rule so that the system checks if the size and material of the work order is the same as the closest pipe?
Absolutely. Yeah, so that type of simple query logic is certainly available in ArcGIS Pro, and the power of spatial analysis, is it the same as the nearest pipe? We can either, do that manually and then turn that process into a tool or geoprocessing model. It'd probably be a simple buffer with the same radius as my snap, and then check, and then potentially join the points to that matching main. That's actually a really great idea and would improve the integrity of this entire process.
Great, thanks, Janice. We do have several questions about insights for ArcGIS. We got feedback from one of our attendees that didn't know about the capability. So they're asking if Insights is available through Pro, or how is it used from a standard ArcGIS license? So can you help clarify that, please, Jonas?
Sure. So Insights is a browser-based application, and it's available both through Portal for ArcGIS as part of your ArcGIS Enterprise deployment and through ArcGIS Online. So Insights is available probably to the majority of users on this webinar. Now, the one thing I want to point out is that this capability to connect directly to enterprise databases is currently only available in the Portal version. So if that's a big item of interest of you, connecting directly to the back end of these CMMS or asset management systems, you probably want to look at the Portal for ArcGIS version of Insights. But all these other capabilities that I showed, the connection to the Living Atlas, the self-service analytics, available both through Portal and ArcGIS Online.
Great, thank you. A couple more questions regarding insights. Users want to know if they can share the dashboard in a website or in another system.
So what I can do is share out this page, and I can embed that in a website. I can embed that in another system. I believe it's just a simple iframe. So short answer is yes. And the really exciting thing, it's actually in the latest blog post from the Insights team, is creating these advanced filters and having that carry over to the page you're sharing as well. So answer is yes, and some really exciting new functionality as well.
All right, very good. We have a couple questions regarding the break rate. Can you speak to, let me see here. When you did create the break rate, did you take into consideration multiple years of great data? And is the rate something along the lines of breaks, for example, breaks of 100 miles per year?
So I'll admit in this example, I kind of did it really quick and not as thorough as I should have for really good data. So I just quickly divided the number of features that had breaks by the total number of features. I'm not even sure if I took into account the fact that I was duplicating features in that data set to give you an idea of the quick visualization. So when you actually perform this process, I recommend being very thorough when you do these break rate calculations, and also make sure you're taking into account, if you can, pipes that have been replaced, right? Because we don't want to, overstate the numbers here. So it's still worthwhile to do, just a quick normalization process, but definitely iterate on that and refine it with whatever information you have to make sure that's the most accurate break rate possible.
All right, very good, thank you. Another question around the break rate. So then you would have to calculate it each time, or will it update as the data changes?
So that's a really good question. In this example, I just performed that calculation in Pro and then published up a static table up here to my Insights workbook. So in this workflow, no, but we could potentially either create a web tool or a geoprocessing model that runs as a web tool that can continuously update that data. One other potential is just looking at the real-time capabilities of a tool like GeoAnalytics Server to potentially calculate these rates on the fly when updates are performed on the data. So that's actually one of the, in my opinion, undervalued or underutilized aspects of GeoAnalytics is just back-end data processing and management. So that's a great idea, and we can definitely look at making this more real-time and more dynamic.
Very good, thank you. Okay, we have some questions around the scikit-learn that you talked about and demonstrated a little bit here. Matt is asking if you recommend preparing the data and working with it inside of Jupyter Notebook, then pulling it into ArcGIS for spatial visualization.
I would say both. My strength being GIS and GIS applications and the desktop tools, I would start and end in GIS applications. So absolutely. And remember, whatever results we get from the tools available in libraries like scikit-learn and other machine learning tools, absolutely leverage the powerful visualizations available in ArcGIS. I mean, we've created great integrations with the Jupyter notebooks where we can bring in maps and detailed and graphic item pages and different things in the script itself. But once we move out of this scripting world and into the world of sharing these results and creating information products for end users at an organization, I'd highly recommend ArcGIS. Configurable apps for non-technical people, power tools like ArcGIS Pro for the more GIS savvy people at the organization.
Great, very good. Thank you, Jonas. We do have a couple more questions, and we can email you with some feedback for those. But I do want to be mindful of the time, knowing that you have to get back to work and your day. So with that, I want to thank you all for joining us today. That concludes our webinar on the power of ArcGIS and predictive analytics in water utilities. And thank you, and we hope to see you soon at the water conference. Have a great day.